Hi, so tonight we're going to be doing the coding part of the portion as well. So first things first, we need to import some libraries from Python. So that would be that's just some math commands. Sci optimize. I'm going to import root scalar. We also want to import some plot things. So we're going to make a plot today too. Plotly dot graph objects as geo, and we're going to import plotly dot io as pio. Let's make sure this is right. No issues. Cool. Now, next we need to do some actual answering the problem. So now that we have that, we can define our input h over r as mp.linSpace. And what this does is the first parameter equals the lower bound. The next parameter is the number of equal objects, and the last parameter is the higher bound. So what this does is it makes it from 0 to 10 equal an array from 0 to 10 with spacing of 1. And that's allow us to make the graph. Now the next thing we can do is we do specific gravity, which is the actual thing we want to figure out, and that would be what we found last time would be 1 minus mp dot art cosine of 1 minus hr minus mp square root of 2 times hr minus hr squared times 1 minus hr. And remember, this is divided by mp dot pi, divided by pi. Oh no, what do we have here? Oh yeah, mp dot square root, sorry, mp dot square root. And another error is I can't type it out. Finding out. So this is HR. Oh yeah. So this is minus 2 times HR. Oh yeah, 2 times HR. That would be HR. Cool. Now that has no issues. Cool. Now next, we're gonna do the actual solving the problem first and then plot. So to solve, we want to make a function with the input HR, and that returns what we have up here. So up here is this. So we're going to take that, copy, paste that, 0.8. Now we're solving by 0.8 because this solves for when it equals 0, so which is when it has a solution. So we take that. Now after that, we need to print the actual result, and from that we equal root scalar f bracket equals 0.1 and results. Aha. Sorry, so we need to find a function up here. There's f. Yeah, there we go. And here we see the expected value of 0.5081. Now, from here, we can do a nice plot to see what the relationship between specific gravity and HR look like. So let's do that now. So first thing first, we're gonna make a figure. Figure equals geo dot figure Next, we're going to add the axes and what they mean. So fig dot add scatter, where our h axis is going to be HR and our y axis is going to equal SG. Look here, now we have that. So this is what it looks like in a graph, but you know, this isn't really good. We can't really do anything with this. It's kind of unwieldy and unsightly. There's no axis graphs on the title, so let's add some stuff to that. So first things first, adding a dark background would be nice. So we're going to add a dark background, which means layout, just template, PIO, the templates. Called Plotly Dark. Now that should make this dark in the background. Yeah, as you can see, that's what it does. Next thing we want to do is we want to make the size a bit nicer. So fig dot update layout dict the height equal 400. Width equaling 500. We want to add some other stuff. We have x-axis titles, x-axis title, even that equals h over r. A y-axis title, and that's going to equal specific gravity. And yeah. And we will also want to add a title to the graph itself, so that would be title equals, let's say, specific gravity versus h divided by r. H divided by r. See how that looks. Yeah, looking great. Yeah, specific gravity versus HR. No, that's really all. It's it. Cool. So thank you guys for watching. That's it. Just quick overview. We inputted libraries from Python, and then we made h over r be an array to get our graph of values down here. As you can see, you can put one in here and it pops out a value. Specific gravity is just the y, and then we define in this to actually solve the equation. We have a function where we define it as this minus that, where we have one being what we're trying to find, and this being what s is actually equal to. We're trying to find where this is 0, and that tells us that the specific gravity is 0.5081, and this is just making a graph where we have HR our x-axis and SG is our y-axis. Down here, it's a graph. Thank you guys.